You see, I was pretty sure that we were supplying it with integers. So, where's our chunk renderer here? Based on that, but apparently not. Vertex attribute 3 requires data of type int, but is being supplied with type float. Okay, no. Material is an integer and it's in. And 3 makes sense because then 0, 1, 2, 3. Where is our chunk render? Is here. And when we're generating it, we are using the local. We don't say anything about the type. We're just saying, here's a load of data. Which reminds me that I want to go for the local vertex data here and say that this is a GL uint. Just so that's done. So what's going on here? I think this is one of the cases where we go for a Google. Here, vertex attribute is requires data of type int, but this is supplied with data of type float. Can't get integer vertex working. Int stride 32. Order offset. I want to change the user. What just happened to the music? Apparently the music just decided to die. For some unknown reason. Gonna try and find some other music. How about something like this? And I want something around here. That was not particularly useful. So there's something called GL attrib I pointer. Otherwise it converts it to a float. So we're gonna too many arguments, expected 5. Okay, so let's have a look at that. So GL attrib vertex attrib I pointer. So we need to give it the index, the size. Let's switch over here. So index, size, type, and then the stride and the pointer. So we just kill off this normalized thing. So apparently GL attrib pointer is for floats. No matter what you give it, it'll output a float, either doing normalizing or converting. And if you want integers, attrib I pointer is the way to go. So we've compiled. Let's give it a spin. It's still complaining. Anything else I need to do? No, that looks reasonable. Okay, now let's do a quick GL vertex attrib I pointer. Index size type. Yeah, that makes for I only the types byte, unsigned byte, short, int, and unsigned int. Values are always left as integer values. So L are double precision floats. Not what I'm looking for. That doesn't make a lot of sense if you ask me. So I found the local vertex buffer, and no matter what, I'm definitely doing that. So let's take a look. I'm looking for the material. So what I want to do is I want to output material, and then I want to output the material attribute. Just check that that is in fact the one that is 3. Gonna switch over, wait for it to link, and reload. So yeah, that is the one that's 3. Oh, requires data of type int, but it's being supplied with unsigned int now. That's the difference. So unsigned int, signed. And we get a complaint. Reserved keyword. Uint? Seems likely. Convert that and convert that. And we'll just take out this because then we can just compile it. That should. Yeah, okay, so what we've done is that we've pulled out that debug for the vertex. These two are now unsigned integers, and what we're taking in here is also an unsigned integer. So let's just take a look at whether that works. So we refresh here. Something's not linking correctly. No operation minus exists that takes a left-hand operand of type flat in medium uint and a right-hand operand of type constant, or there is no acceptable conversion. Yeah, so I can't subtract 1 from an unsigned integer, is what it's telling me. Well, we'll just use the varying material directly. Doesn't really matter that much yet. We'll work on it in a moment. So we're just going to recompile. So the thing was that we had a -1 here, which I've just removed now. Now we should get essentially stone and grass. So let's see what happens. It's looking interesting. I'm sort of curious about the amount of stone. I would not expect to see any, and I would definitely not expect to see split faces like this. That I should definitely not be seeing. So we're probably doing something wrong. Surprise. So in our chunk renderer, less than the number of edges is the chunk size +1. So yeah, I need to do this in different order because this is wrong. We're going to be indexing weird stuff. So what I want to do is that I want to iterate over these, and I want to do it based not on the number of edges, because I'll take care of that in a moment. Do we have, no, we just have chunk size. So based on the chunk size, because I want to iterate through all of the chunks. Is it here? So we want to go for chunk size here. Now the thing is that I then want to go through for each of these vertices and set this. So what we're going to do is we're going to get the material, or the mat, it's going to be called here. Auto mat is going to be the value of that chunk. And then I am going to, for each facing or each direction here, actually not for each direction because I want to do this correctly. So for the vertices at X, Y, and Z, facing in negative X, so negative X is left, or also direction west. I want to set that, and I also want to set that for Y plus 1, Z plus 1, and both Y and Z plus 1. Yeah, Regan, you snooze, you lose. You gotta be quick to keep up with what's going on here. I mean, it looks really horrible at the moment, but I mean, something's happening at least. So then also for the eastward facing one, so this is going to be east. And then the X is 1 higher, because that's the east side of that vertex. And then we have similar stuff for, say, we move on to the Y. So Y is up, down. So Y plus 0 is actually down. So for the bottom of this face, I want to set this material. And then for up, or top, or whatever, I'm guessing it's called up. thanks for the tip once again. So thing we're doing here is to generate our local vertex buffer. We're running through all the chunks, and then we're getting the material for that chunk. And then for the west-facing vertices, the first 4 here, we set that. Then the east, down, and up. And we need north and south, but I have a nasty suspicion. So it's going to be a little moment. There we go. So now we just need north and south. So for north and south, we have y changing and z at 0. So z 0, that's negative z, that's north. At least I hope I'm getting this right. And then positive z is what we call south. So yeah, that's a nice bit of assignments there. That can't possibly go wrong, or something along those lines. So let's give that a go. We just reload, run that. Still getting weird crossovers here. But it looks a lot more consistent at least. So I'm guessing that's a good thing. So, what did I get wrong? So we're allocating hopefully the right amount of space here. Yeah, we're edges times edges times edges times edges times 6, which is the right size. We have our wonderful little vertex index function that should take care of getting the right vertex index here. So we're going for x, y, z, and a spacing direction. So if we're adding an x positive face here, which is east, which is that one, we're going with x plus 1, then y plus and minus 1, plus 0 and minus, plus 0 and plus 1, and z plus 0 and plus 1. So on east, should be those ones we're setting. The west is the same up here. So for down, we have y plus 0, and for up we have y plus 1. So for down we have y plus 0, and for up we have y plus 1. And north should be y plus 0, or z plus 0, and south should be z plus 1. So that all looks about right. And that means that in theory, every material should be set once, and it should be set correctly. That's not exactly what we're seeing. So what is going on here? The weird thing is that I'm getting both stone, grass, and dirt. I would only expect to get grass and dirt at the moment. And in fact, if you kind of look at it, it looks like it's, well, not really following a pattern. Might just be my eyes trying to pick out a pattern in it. So let's just, for the sake of it, the material is now, what do I use GL uint for this, so GL uint material is now material 1. So that should be dirt. Everything, if it works, should be dirt. If this doesn't work, it means we're indexing something we haven't defined. At least that's my logic right now. So let's see what happens. So yeah, what I just did here, instead of pulling the actual material, I just set it to 1. So everything should be dirt. Everything is dirt. So that's a good sign. So what we're going to do now, we're going to actually get the chunk data here. We're going to get it as a GL uint just because. But what we're going to do is, if this is 0, we're going to let it be 0, otherwise we're going to set it to 1. So that means if anywhere we're actually using a vertex buffer that has a material of air, we'll see stone, and otherwise we'll see dirt. So we should see dirt everywhere, but I don't think we will. I think we're going to see some stone. We're seeing a lot of stone, which we should not. So some of these vertexes are getting their material set to be air, essentially. Or at least one of their vertices is set to air. Thing is, it doesn't have to be all of them because we're flat shading here. So if we just jump over to the code here, I'm going to switch these, put these into blocks quickly so that we can hopefully see them a little bit better. So this should take all the west-facing edges. Essentially, we have two sets. So we have west, which looks right. I mean, we're going through all combinations of y and z. For 1 and 0, we've got 0, 0, 1, 0, 0, 1, and 1, 1. And then we do the same here, but with x plus 1. Then we have all combinations of z and x here. And we have y set to 0. And then we have all combinations of z and x again, with y at 1. And then we should have all combinations of x and y, and all combinations of x and y, with z as 0 and 1. It looks alright to me. Now, as I step through, oh, crap. Okay, so the problem here is that I'm reusing vertices between blocks. I think. So like this edge vertex here, facing out towards me, it's both used in the blocks that are visible and the blocks above it. Which means that the block above it is setting that one to air. Now I could fix that for error and just say don't set. So that block here is setting its vertex, or that block above here for air is setting that vertex to air. Now I could fix it by not setting any of these to air, but that won't work here, where the top one might be dirt and the bottom one might be stone. It's still going to reuse that vertex across. So that's what's going on. Now, I'm not sure I can stop reusing vertices without any problems here. How would we want to do that? I mean, it's basically, we're going to be redoing the what's it called? The chunk renderer, which is not particularly fun. I mean, it's not impossible, but it's definitely not fun. So if we're going to redesign the chunk render, we have to give each block individual vertices so that we can assign individual properties to that block. Now that means that for each block we're going to store 8 vertices, and there's 16 by 16 by 16 vertices. So that's 8 times 16 times 16 times 16, which is, it's within range of doing in an unsigned integer or in unsigned short, which is twice as large as that. So I guess that's what we'll be doing. It doesn't seem like the most fun thing in the world. But looking at the time, I think we're going to save that for next week. Kind of sucks to stop in the middle of something, but we've been going for a little over 3 hours, and I am getting really, really, really tired at this point. So we are going to wait with that until next time. So next time, we're redoing the chunk renderer so that we can actually get proper materials in. But for now, that's all we're going to do. I'm just going to reactivate that because it makes it look a little bit more interesting. I'd still claim that we've done a fair amount. We've been struggling a little bit with the usual stuff, which is texturing and vertices and stuff like that. But we've got a skybox, we've got multiple different types of textures running. We just need to get them in the right place. That's going to take a little bit of work. But yeah, that is going to be it for today. I guess I'll see you all next week. Same time, same place. So long.